Okay, let's get started. It is noon, and I think some people will trickle in. But at the same time, I have a couple pages of introduction, so they won't miss James, at least they'll miss me. That might be strategic. I'm Cindy Brewer. I'm the Associate Dean for Faculty Affairs in the College of IST. Some of you might not have met me yet, so I thought I'd start there. And so happy lunchtime and welcome. Thanks for joining us to participate in this lecture and recognize one of the College of Information Sciences and Technology's outstanding faculty members. Before we get started, a couple reminders. The session's going to be recorded and it'll be available on the college's YouTube channel. So if there's cool things in here that you want to revisit or point your students towards, that'll be a possibility. We'll have question and answer after the period, so that's when it's a good time to ask questions. And also get some questions fomented in your mind so we don't have that awkward long gap. And I'd also like to thank Joni's team and Joni for organizing all the pieces of this talk and the award and the session. So for the reason we're here today, the George J. McMurtry Faculty Excellence in Teaching and Learning Award, that's a long award name, recognizes recipients who bring innovative teaching, a commitment to learning, and creative interfaces to their classrooms. The award is one of the highest honors given in the College of IST. It's awarded annually thanks to the generous contribution of Dr. George J. McMurtry and his wife Margaret. George McMurtry was the former Associate Dean of the College of Engineering who was instrumental in founding the College of IST. So a connection between those two colleges. On behalf of the College of IST, we are forever grateful for the McMurtry family's generosity and continued support of IST. So now I'm pleased to recognize the recipient of this year's George J. McMurtry Faculty Excellence in Teaching and Learning Award, Dr. James Wang.
Thank you.
James joined our faculty in the college as a member in 2000, the year 2000, making him one of the first and longest tenured faculty members in the college's 25-year history. And we just celebrated that 25-year history last month, which was a lot of fun. He now holds the rank of Distinguished Professor of Penn State. He was also held the endowed PNC Technologies Career Development Professorship in IST. When you become a distinguished professor, they make you drop your other distinguished professornesses. So that's a curious thing about the Penn State Award. His research was primarily funded, or has been primarily funded by NSF and NIH. He seeks to advance knowledge related to the analysis, management, and understanding of large and complex visual data. For these efforts, he received an NSF Career Award, probably early on.
Right, long time ago.
And 4 Amazon Research Awards. His work has been featured by PBS, Forbes magazine, NPR, Scientific American, and many other major media outlets. In addition to IST, he's also an affiliated professor of the Molecular, Cellular, and Integrative Biosciences program. And he serves as the founding co-director of the Intelligent Information Systems Laboratory. He previously served as both a visiting professor of robotics at Carnegie Mellon University and a program manager in the director's office of the National Science Foundation. Thanks to his leadership in and out of the classroom, his students have pursued impactful careers in research, academia, industry, at leading companies such as Adobe Research, Apple, Facebook, and at top universities such as Brown, Johns Hopkins, University of Cambridge. Hopefully they invite you to visit. No. He has been a tremendous asset to our college as a scholar, a teacher, a mentor, and a colleague. So on behalf of the College of IST and our students, I'm pleased to recognize him with this award. James received a cash award.
Okay.
And a budget allotment to use for learning enhancement initiatives. His name has been added to the award plaque currently displayed in the Hanson Lounge on the 3rd floor, so at the top of the stairs there. And he also gets a bag of loot.
Oh. Thank you.
You wanna pull that open?
Oh, do I need to open?
Sure, if you want.
Oh, I guess it's packed. It's Hensley meeting line. So, yeah,
Yay!
thank you.
And it's got a customized plaque there on it. So, thank you. New duties as assigned for this award is trash cleanup.
Okay.
So now I ask you to join me again in recognizing James as this year's recipient of the George J. McMurtry Faculty Excellence in Teaching and Learning Award and giving him your attention during this talk. So congratulations, James, and I'm handing it over to you.
Okay, thank you, Cindy. And thank you all for coming to the talk. Hopefully, you don't have to skip your lunch. I will try to make the talk as interesting as possible. So the talk title is Unleashing the Problem-Solving Potential of Next-Generation Data Scientists. I myself has been a data scientist since my graduate school over 30 years ago. So it's quite a long time. But I've been working on this data science problems for the last 30 years continuously. And more recently, because of big data, we shifted more from what we call data science to AI because there are a lot of things we can do with neural net and big data now. So I will talk a little bit about our research also during the talk. So I'd like to start by sharing this photo that I took during my sabbatical in Europe last year. So I spent the whole year in the last academic year in the UK, but I also visited various places in Europe. It shows a swan just as it taking off from the ocean surface near the island of Ærø in Denmark. I'm not sure how many of you have been to that small island, but it's a very beautiful island. I was on a ferry, and there were literally 1,000 swans in that area on the ocean surface. But most of them were just resting there, except for this one was trying to take off. And as some of you may know, swans are really large and majestic birds. And some of them are as tall as I am, with a wingspan of maybe 7 to 10 feet. So they are, but we don't see them very often in the U.S. However, they are everywhere in Europe. So interestingly, no matter which country you go there, you can see a lot of swans. And watching them taking off is an incredible display of, movement, grace, and determination. But baby swans, we call it cygnets, right? They are just about the same size as the duckling when they hatch, but then they can grow very, very rapidly. So teaching, in my opinion, especially in the field like data science and AI, feels very similar. We have to guide the students through uncertainty. We have to help them to build the momentum so that they can become successful. And like the swan, students need to have the right mix of encouragement, guidance, and support to truly reach their full potential. And today, I hope I can share some of the reflections I have during my teaching journey in the last 25 years in IST, and how I've worked to help students to gain that momentum, that is how to give them the right tools so that they can take flight in their learning and beyond. And here is just an outline of the talk. At the beginning, I will talk a little bit about my own academic journey so that you can see my background. Of course, Cindy already talked about my various background, but I will try to also give you a little bit more. Then I will talk about my teaching philosophy and the teaching strategies, in particularly related to this relatively new program called data science, which I've been teaching in the last 7 or 8 years. And then finally, I will talk about challenges we still face in teaching and also conclude. And before that, I'd like also to take a moment to thank George McMurtry for this award and to express also gratitude to those who have supported my teaching journey, including my colleagues, mentors, students, and friends. So I begin now to talk a little bit about my academic journey so that you can see how my own journey shaped my teaching philosophy. So I completed my undergraduate education in another Big Ten university, University of Minnesota, so the Gophers, and where I studied mathematics actually, and with minor in computer science. And afterward, I moved to the West Coast for graduate study, where I spent 6 years but I studied 3 different fields, mathematics, computer science, and then medical AI. So this experience really allowed me to witness firsthand how different fields guide their students, how different fields teach their courses, right? And how different fields prepare their students for their future careers. And that really helped me to be a professor in data science, because in data science, as I will later talk about, is exactly at the intersection of mathematics, computer science, and domain knowledge, right? So basically, my graduate school experience prepared me with math, computer science, and the medical field. And in year 2000, I joined the IST as a fresh assistant professor, shortly after the college was created in 1999. So I remember when I first came here for a job interview, I was only, I only needed to talk to 5 faculty members because there were only 5 faculty members before me, right? But now, of course, the college has grown, quite dramatically. Now we have maybe dozens of faculty members and hundreds of students, and we have a number of majors and minors and so on. But I have a very limited industrial experience. I only did some summer internship when I was a grad student. I visited IBM Research, NEC Research, and SRI International. So I did some research during my graduate studies in the industry. So I've stayed in IST since 2000. I've never moved around, except that during sabbaticals, I spent a year at CMU, and I spent a year in the UK, and I spent another, I think, half a year in Europe, and I also, took off a couple of years to serve in the National Science Foundation, because I've always got funding from National Science Foundation, so I felt like I need to pay back by, serving as a program officer at NSF. And that photo was me, in year 2000. Obviously, I have grown quite older now. Yeah. So my research group also conducts some really exciting data science and AI research. Over the years, we've done a lot of very interesting topics. Here, I'm just showing you some of the projects that we have right now, on data science research. They are all funded by federal government, including NSF, NIH, and NEH, as well as some other foundations. So this research has really inspired numerous ideas for me for teaching data science to undergraduate students. For example, we collaborate with biologists in Penn State on bioimaging informatics. Here I'm showing you, let me turn on the laser pointer. So here I'm showing you, for example, 3D segmentation from microscopic images to get the guard cell in order to study the cell behavior, for example, in a drought situation. And then the second one is one of our current core area, which is affective computing and robotics, where we try to model humans' behaviors, like humans' bodily expressed emotions. And this is one of the areas that's not very heavily studied, because current AI researchers mostly focus on, for example, annotating real-world images or videos, rather than in the space of emotion intelligence. So that's one of the areas that we are still leading in the research space. And we have also studied the severe weather prediction using satellite imagery, and we studied the fundamental machine learning methodologies, like, for example, clustering of discrete distributions. And then we studied the AI inspired by child development, because current AI, as use a lot of data, right, to train. For example, if you're talking about ChatGPT, GPT-4, for example, is trained with dozens of trillions of documents, and the GPT-5 probably would be in the order of 100 trillion documents. But then humans, when we were born, we stay in a house for the first 2 years primarily. We have very limited things coming through our eyes, right? But still, in those 2 years, we built probably most of our human vision systems capabilities, right? Of course, a lot of that has been coded in our DNA through, long term of evolution, no question about that. But still, it's amazing human child, what human child can do in just, in the same house for like 2 years of time, right? And so here we were inspired by child development. We try to develop next generation AI that would not rely heavily on a lot of training data. Another area we are really interested in is the intersection with humanities and art. And there, we have been, we studied, for example, using computer to model the brushstroke style of Van Gogh. And more recently, we are studying Constable's claws. I see my collaborator, Cassie, is sitting in the room. And then in the medical area, because my graduate study was in the medical school, so I'm always interested in medical collaborative projects. And here, this is one image that was reported by Fox on our research on stroke analysis. So how we do stroke early diagnosis through just an app, right? So the app can take a video of a person going through ER if they are thinking they have a stroke, and then our app can potentially tell the ER nurses whether the person has a high chance of having a stroke or not. And we also study, for example, placenta. And in all of this research, we collaborate with different parts of the campus as well as beyond Penn State. For example, we work with people in agriculture, art history, biology, meteorology, neurology, nutritional science, psychology, pathology, statistics, and so on. So it really gave me a lot of inspiration on how data scientists can become successful, right? You do need to talk to a lot of other people. So here, over the last 24 to 25 years, I've had the privilege of guiding many talented and dedicated students, both at the undergraduate level and the graduate level. Here I'm just showing you some of the pictures because we often go out to have a hike, for example, and sometimes we sit in the campus to talk about research. So over the years, of course, sometimes I really miss the days when I was almost as young as my students. And as Cindy has already said, my students have gone to very good places. Like undergraduate students oftentimes end up in very good graduate schools, including some of the leading schools in the whole world. And for PhD students, they go on to take a lot of leadership positions. For example, one of my students were the director of engineering at Meta, and he oversees hundreds of scientists and engineers, and for all the things are related to images and videos on the Meta platform, right? And now he's a AI director at Databricks, and also some of them become faculty members too. So because the particular award, which is center of today's talk, recognizes classroom teaching, so I will focus the rest of the talk on classroom teaching. So my teaching philosophy has also evolved quite a lot over the years. Since I joined the IST in 2000, because at the earlier time, we had a small number of faculty members. So faculty members who have more exposure in their graduate school, like me, has to teach a lot of different courses. So I've taught quite a number of different courses, including databases, including computer networks. I see Mark sitting here. He has taken my course. And discrete mathematics, emerging technologies, advanced topics, and more in recent years, I've been mainly focusing on data science, teaching this course called Data Science 340W, called Applied Data Sciences. And in this talk, I will use DS 340W as an example to illustrate my teaching approach. For this particular course, this is a junior to senior level undergraduate course in the relatively new data science major. And I developed the course in around 2017 to 2018 and have been teaching this every year. So if I were to summarize the core values that guide my teaching, right, they would be first, fostering critical thinking. I will go into details in the later slides. And second, promoting hands-on learning. And third, encouraging lifelong learning. And last but not least, prioritizing student success. When I started as a junior faculty, I took more of a traditional approach because, as I mentioned, I graduated from mathematics programs. So in mathematics department, they teach math just by writing things on the blackboard, equations and equations, nonstop. And in computer science, I also been through computer science. In my computer science program, they don't use blackboard as much, but they go through slides and slides, nonstop. So very technical courses. But however, in, for example, medical AI program, there are a lot of hands-on experience because medical AI is all about applying AI or developing AI, for the medical applications. So there are a lot of hands-on teaching. So based on that experience, I sort of have to think about what is best for our courses, right? Of course, in the early days, because I was teaching technical courses like databases, like networking or discrete math, so I had to sort of adopt the more of a mathematics or computer science style of teaching, because I think that's probably the best way to convey a lot of technical information to students. But despite my efforts, I've often found students getting lost because the pace that I covered the topic, I have to admit, it was quite fast. It was frustrating at times. I can also imagine many students felt the same way. And that style of teaching, even though it worked well, in the past and also worked well for certain disciplines or certain technical courses, but today, because knowledge is abundant, right? If you go on, say, ChatGPT, ask a technical question, ChatGPT can give you the answer quickly, And also, on the internet, you can find all sorts of materials, right? Even MOOCs. So the question today, with all the AI and the internet, how can we still teach students in a way so that, student can also benefit from your teaching, right? Rather than, just teaching them in the same way as what ChatGPT can do or those MOOCs can do, right? So that is a question that I have been always thinking. And I realized that I need to change my teaching approach, right, to fit such a particular course, right? Because right now, as I said, I'm focusing on this course. So for this course, because it is a junior level course, and before this course, students have already taken technical courses like machine learning, like databases, like, for example, cloud computing. And they have also taken ethics-related courses. So the question is, how do we make this course a course that they can benefit from, right? So this course basically is between the technical courses and the next step, which is they can solve real-world problems. So we need to really prepare them so that they can be problem solvers. So how do we do that is the main question, right? So rather than simply delivering knowledge, I think I need to equip students with the skills to become independent and lifelong learners. Why is that? Because as I guided so many PhD students, I know that in this field, like data science and AI, you cannot survive even if you're not a lifelong learner. Like, for example, sometimes I talk to my past PhDs at YCs, and they have been telling me that even though they graduated just like maybe 10 years ago, now they have to totally relearn the materials, right? Because the materials they learned in the old days, not old days, like 10 years ago, was mainly like, say, support vector machines, like classification trees. But these days, almost everything you got to have to try neural network first, right? So they have to learn neural networks, from scratch. Because back then, like 10 years ago, we didn't teach them neural network because at that time, neural network was considered a dead field, right? For many years, from 1990s to about 2010, people thought neural network has no hope because it was just not scalable for today's large-scale problems. Until people suddenly found a way to run neural networks on GPUs, then everything has been changed, right? So now people want to try neural network first before they even think about other tools that we have been using for decades. That's one of the reasons I think students, no matter whether it's undergraduate or graduate, data science or AI field, they have to have the skill set for lifelong learning. So that's why throughout this course, I try to, teach them in that way so that they can eventually become independent and they can learn to learn. So now, so I've been doing data science research for the past 3 decades, right? So I also know that, PhD advisees, for example, with similar technical skills, because they all graduated from my group, so they have very similar technical skills, right? They are all pretty good, but still, I can't really tell apart, who has better technical skills from the others. But then after, like, say, even 10 years, they can end up with very different levels of career success, right? As I mentioned, one can be, directing all the image and video information on the Meta platform, right? Others could just be a software engineer in another company, right? So I wonder, what makes the difference, right? Definitely, I don't think it's the technical skill. And from what I can see is that, there are a lot of other things that make the difference, right? For example, technical skills, of course, is really important. Here, I'm showing you what I thought would be the most important skill set. Like, for example, technical skills, including mathematics, statistics, programming, data processing, machine learning, visualization, cluster computer, and software engineering, domain knowledge. So all these I consider technical, even though in certain domains you may not consider that technical. But I bundle them into this area called technical skills. All these are very important. So that's already quite challenging for data science, because data science, unlike traditional disciplinary field, they only need to study math, or they only need to study computer science. Here, they actually have to know quite a lot of different things before they can even do a problem. But on top of that, they also have to develop strong intrapersonal skills, like, say, personal motivation, because we are talking about problem solving, right? And self-regulation, self-awareness, self-confidence, self-learning, and the information synthesis, right? Because the field is changing so fast. If they are not motivated, if they don't have the capability to synthesize a lot of information, like, for example, the papers coming out every day, hundreds of them, right? Then they can easily lose out, right? And the interpersonal skills, because a lot of data science projects are not done by a single person, but by a team of scientists with different backgrounds. So you do need to have the capability to communicate effectively with other people, like from other background, people from other background. And also you need to be able to conduct teamwork effectively. You need to be able to, have a conflict resolution skill set, right? Every semester when I teach this course, I get, students coming to my office are saying that their teammates are not helping, right? They cannot even get hold of their teammates. Things like that, I have to tell them that this is your opportunity, actually, to learn some teamwork skill and interpersonal skills, right? Because because some students say, can you just put me in a single student team? I'm sick and tired of talking to my teammate, right? But then I said no, because if I do that, it would be easy for me to resolve this problem, but you will lose your opportunity to actually develop your teamwork skill. So I challenged those students to talk to their teammates, right? Try to resolve all these issues, right? So that every student will contribute to the project more or less the same way, so that the project team can have a more ambitious goal rather than just a single person team. And at the end, of course, I was able to convince all the students, with twisting of their arms, I was able to convince them to, work out with their own student team, rather than, having me reassign them or putting them in a single student team. And finally, problem solving, because data science, even though at Penn State, we put them into 3 different options, like one is computational data science, one is statistical modeling data science, and third is applied data science, for a variety of reasons. But however, data science can only exist with applications. Data science cannot exist without solving problems. It's not like a traditional mathematics or statistics or computer science. here, data science can only exist when we are solving real-world problems. So I tell students, even though you have 3 different options, but in this course, everything is applied data science, right? Because data science can only be applied. And so in problem solving, they need to have the capability of brainstorming, because a lot of real-world problems are not well defined, right? What tools you can use or what methods you can use to solve them is not really that clear oftentimes. So they need to have the brainstorming capability. They need to have a critical thinking capability. And they also need to have a sense of creativity. For example, in this course, we have a semester-long project. And I tell them up front that even though I give them the option to choose their own topics, but I want to see some level of creativity there. I don't want them to just reinvent some other people's solutions or just download a package and run our new data set. All these kind of activities, they don't learn as much. So I tell them that you need to identify what is the creative aspect of your course. What is the novel ideas in this project? What is the novel idea in this project? And also, they have other areas that they need to learn about problem solving. For example, resilience, intense focus, and also review and evaluation. So I will go over some details later. Recently, my colleague Jack Carroll edited a book on innovative practice in teaching in information science and technology. And he invited me to contribute a chapter. I and my PhD advisee, who worked as my TA for the course, wrote a chapter on this course. So if you have interest, you can also read this chapter. It covers more about the objectives and rationale and course design and so on from the course. So I will just talk briefly about some of the ideas I wrote in that chapter. So as I earlier mentioned, if you think about data science as a field, right, it's a relatively new field, even though the term data science has existed for decades. But early times, like say in the 1980s, for example, when people talk about data science, they think about it more of a subfield of statistics. But today is very different from statistics, because data science is actually at the intersection of these 3 circles. So in the middle, that is what I would call data science, because that leverages statistical methods, also a lot of computational science knowledge and tools, and then to solve domain problems, integrating domain expertise, right? It's not just plug and play of tools to data, but rather you have to integrate domain expertise. And then we can extract insights and knowledge from data. So data science involves a long pipeline of things, like for example, data collection, right? Data processing, data analysis, interpreting of data to help make informed decisions, and then solve problems and to predict future trends. Data scientists use a lot of different methodologies, but you cannot just plug and play all those methodologies. You have to know the pros and cons of the methodologies. You have to also know the hypothesis or some of the assumptions you are making by using those tools in order to get the right solution, right? In order to get the valuable information or actionable insights. So it's quite a challenge for an undergraduate major, because undergraduate only have 4 years, right? And they have to know the background knowledge like math and computer science in order to actually solve the problem. So for a course like this, it's really challenging. But however, even though in data science, a lot of that is what we do is probabilistic, right? We use tools to sort of assess the probability of a certain event. But then we can never prove anything. Not like in mathematics or some subfields of computer science. You can actually prove it, just like, for example, in relational databases. You can actually prove, by doing all this algorithm to solve a certain SQL query, it would always solve the same type of SQL query, right? You can mathematically prove that. So based on, set theory, for example. And then you can apply, the same relational database management system with that algorithm to all kinds of databases, whether it's a Walmart or this, some employment database or something else, right? So no matter what data you feed in, you can mathematically prove this algorithm will always work. However, in data science, we cannot do that, right? You cannot prove that your algorithm is always going to generate correct answer, right? You can only trial and error, sort of try it on the data and get the result and see the accuracy, and for example. So all of these things in the pipeline can generate biases, can generate wrong answers if you're not doing it properly. Even though data science cannot prove anything, it doesn't mean data science is not valuable. The reason is that the reason data science is so hot is because there's so much data right now. It's here, I'm showing you a plot from Forbes magazine. It says by 2025, there will be 175 zettabytes of data on Earth, right? And zettabyte is 1,000 exabyte, which is a million, petabyte, and a trillion terabytes, right? For people like you and me, a terabyte is a lot of information already, right? So even for my data science research group, probably we only work on terabytes of information. But here we are talking about on Earth, how much data is there. And this trend is only going up, going up exponentially even. So there are a lot of needs to handle this data, right? And the businesses today recognize that if you cannot handle this data, you cannot win the competition, right? Whoever can leverage this data to generate business insight, whoever will win the competition, right? So moving forward is the same. You do need to analyze a lot of data. And data is also everywhere in our daily lives. Like for example, here I'm just showing you Amazon, right? Amazon users spend $450,000 a minute, right? And Taylor Swift, they downloaded almost 70,000 times a minute, right? And on and on. So ChatGPT uses thousands of whatever this is called, so prompts per minute, right? So data is everywhere, even in our daily lives. And if you drive, for example, autonomous driving cars, a car like Waymo, for example, developed by Google. Actually, one of the earlier employees of Waymo was from my research group as well. And so they generate 4 terabytes of data per day and every day in order to keep autonomous driving car move, right? They have to look at the surroundings with cameras, with sensors, and has to sample the world with a certain frequency, like several times a second, in order to not to hit a pedestrian, for example, right? Or not to hit another car on a highway. So, and ChatGPT, as I mentioned, this trend with hundreds of trillions of tokens, and this trend is just going up tremendously if we are talking about understanding videos, understanding images, and so on. So, and also, for example, with say climate change, right? If we can model the Earth's climate and weather, using say a digital twin, then potentially we can make better predictions and make better decisions on how to how to mitigate the climate crisis. And however, that amount of data is just unbelievably large, right, in order for AI to even look at. And actually tomorrow I have a paper to be published related to the Nobel Prize. So we were invited, to comment on the Nobel Prize, and it will be published by the journal Patterns by the Cell Press tomorrow. And around noontime they will put it online. So I will talk about the this neural net revolution by the 2 Nobel Prize laureates, and also the future of AI. So if we think about AI, has a lot of limitations, right? AI has lack of explainability, has biases, has hallucination, difficult handling out of distribution data, reliance on massive data set, catastrophic forgetting, and vulnerability to attacks, high computational cost, inadequate symbolic reasoning, and on. They are all well documented. But even if AI can be improved, right, over the years, I'm sure researchers like my colleagues will continue to improve AI. But I recognize that even if we can continue to improve AI, there are still fundamental constraints between AI and humans, right? So human intelligence is still far more sophisticated compared to the artificial intelligence. Here I'm just listing some of them. For example, AI lacks emotional intelligence, and emotional intelligence is not something that you can easily teach AI to have, because humans evolved that emotional intelligence over hundreds of thousands of years, right? We have to hunt and we have to form teams. Otherwise we would not be able to survive. And AI is very hard to gain that. And humans also have creativity. Human has imagination. Human has intuition, common sense, ethical and moral reasoning, and intrinsic motivation. All of this, I don't personally see a possibility for AI to get that in the near future. So in this article to be released tomorrow, I actually talked about this in a little bit more details. So for us educators, the challenge is to prepare our students to leverage the unique strengths they possess as humans, right? So that in this world where ChatGPT will be available almost free, right? How can our students still survive, right? How can our students still have a job? They need to leverage their unique strengths, right, compared to computers. All of these are their unique strengths. But for us educators, we need to promote that so that they can best leverage their strengths. How do we do that? So, for example, in fostering critical thinking, there are several different areas that I believe are things we can do. For example, we can encourage students to ask questions like why and how, right? Rather than letting them memorize techniques, they need to do more question like why and how, so that they can actually use that capability, critical thinking capability, in their problem solving for real world challenges. And they need to challenge also the conventional thinking, right? So I will give you an example in the coming slides. And so in my course, I often treat myself as at the same level as students, so that they can easily question me, and also they can easily question their peers, right? I try to build this atmosphere so that students can feel free to challenge their professors. And they can also voice their different perspectives. And also I want students to know that no matter how complex the problem is, they can be broken down into parts, right, so that you can solve them into a pipeline. And this is especially useful for data science, because data science, you really have to go from problem definition, problem formulation, all the way to the end. I will talk about that in more details as well. So they need to have the capability to break down a seemingly very complex problem with so much data, so complex data sets, into something they can model mathematically and computationally. And third, I want them to have the capability to tackle real-world challenges, because they cannot just tackle toy problems in school and jump into a real-world problem directly. It's not going to fly, right? So I want them to be able to tackle real-world complex, large-scale problems and interdisciplinary challenges while in the classroom, so that by the time they graduate, they can immediately solve a different real-world challenge. Lastly, I want them to work in team. I want them to be able to organize collaborative learning activities. So critical thinking, in summary, is just the ability to analyze, evaluate, and synthesize information, and enabling students to approach complex problems with a deeper understanding and innovative solution. So in this course, I use a case study. This case study was a study did by my research group on Vincent van Gogh's brushstrokes. So here I'm showing you, the challenge that we got from art historians at Vincent van Gogh Museum in Amsterdam, where we want to use computers to answer some art historical questions, like, for example, what brushstroke style distinguishes Van Gogh from his contemporaries, meaning other painters of his time. And also, for a particular painting, can we use computer to help date that painting, right? Because for many Van Gogh's paintings, there is information that you can use to date a painting. For example, he may have written a letter to his brother where he described a certain painting, done in a certain summer of a certain year. Then you can date that painting, but for some paintings, you don't have enough information to date that. And his painting only covered about 10 years of span, right? Because he only did painting, did about 900 paintings in about 10 years. And then he suddenly died in the age of, I think, 37, right? So basically a very short span of time, but his painting style has dramatically changed over time. So for art historians, sometimes the key question is, can we really date this particular painting? You cannot use chemical analysis because the span is so short, right? You cannot really accurately date that based on other analysis. So in this case, for example, here I'm showing you some of the paintings done by his late period, like in 1887, he died in 1890. So in 1887 to 1888, 1889 to 1890, only the last 4 years, you can see a dramatic change of the brushstroke styles. Like, for example, 1887, you don't see a lot of very long, very curvy brushstrokes, but in the last year, final year of his life, his brushstroke become very curvy and very long brushstrokes, right? So even in the last 4 years, there are a lot of things that has changed. So actually, PBS Nova Science Now put out a video TV program on our work. It was aired in 2 seasons back, 2007 and 2009, I think. And if you are interested, I think there's a copy on YouTube. So in this case, I teach students that in order to answer this art historical question, we cannot just throw these paintings into, say, support vector machines or neural net, because they cannot explain, right? They cannot give us explanations, because art historians not only just want to know some numbers. Those numbers are meaningless to them, right? Like a probability. What does it mean by a probability, right? This painting is either done by Van Gogh or not done by Van Gogh, right? So probability does not really mean anything. So here, what they want to know, for example, what characteristic of a painting make it a Van Gogh, right? What are the differences in the brushstroke styles? And what characteristic make it a painting done in 1890 rather than 1889, for example, right? So in this case, we do have to take the painstaking approach of extracting brushstrokes, because for Van Gogh paintings, everybody understands that the brushstrokes make a difference. So we have to actually develop our own computer vision algorithm in order to extract the brushstrokes. And because there are thousands of brushstrokes in a painting, this algorithm alone has a lot of novelty, because you cannot just easily extract all the brushstrokes. If you think about computer vision's segmentation, they segment a car from an image, right? A car from the background, or a car with tree, and pedestrian from the background. That's like 4 different things. But here we're talking about thousands of things, right? So you have to be able to do that. And that's one of the reasons, one of the most impactful AI journals published the work, because the algorithm itself has a lot of innovation. But once you have the brushstroke extracted, like in the earlier slides, right here, I'm showing you the extracted brushstrokes. Each brushstroke is given a unique color. They are random colors. So once you have this, then you can actually study a number of things based on the brushstrokes, like individual features, like length, width, and width variations, shape, and so on. And you can also talk about the interaction, how each brushstroke interact with its neighborhood. And then you can also look at the global features from the whole painting perspective, like number of brushstrokes extracted, average and quartiles of the features and orientation, and dominance, and so on. So with all this information, then you can provide explainable insight about Van Gogh's brushstrokes to art historians, so that they can even appreciate, right? Because you can talk about it, because there are a lot of rhythmic structures in the brushstrokes that distinguish, for example, Van Gogh versus his contemporaries. That's one of the findings we found in that paper. And also we know that, for example, in the later period, there's more curvy and more longer brushstrokes. So all this can be found once you have the brushstrokes. And also, because of this, we are able to actually answer the art historical question. We know that these 2 paintings where art historians didn't have enough information, we were able to date them into the later period. And then this particular one is dated for the earlier period. But if we compare the landscapes, then we can also say this may have been painted in the later period. So through this project as a case study, I also teach students about the whole pipeline, because if you look at this project, from the problem formulation to data acquisition and to data preparation and then to exploring and feature engineering and modeling, all the way to assessment and drawing actionable insights and communicating that information to the actual say art historians and also the readers. How do we do that? In this whole pipeline, there are a lot of things students can learn, right? Because, for example, even from data acquisition perspective, if paintings are digitized differently, then they can have different level of contrast. Then that alone can throw a lot of the modern machine learning techniques to useless, because they're just biased based on the data acquisition alone, right? And some of my colleagues in the field, they also studied Van Gogh, and they later also admitted that their techniques would not be useful because of differences in digitalization. But our technique, for example, when we extract the brushstrokes, we can see actually whether the brushstroke extraction is correct or not. And later we totally throw away all the information about the contrast, because we only studied the brushstroke the extracted brushstrokes in their shape and other characteristics, but not the details like the contrast. So that's just one example, how this case study can teach students about the importance of various aspects of the pipeline. Another example is that if we only have, say, 100 paintings to study, you cannot throw them into, say, a large model like support vector machine or neural network, because that would be, you can easily overfit that. You can get results, but the results is meaningless, right? So in that case, we have to use more of a simple but fully explainable technique so that we can explain, the differences in the different characteristics of the brushstrokes. So then, in terms of the real world, right, as I mentioned, data science has to solve real world problems. And many people also say that data science is now the fourth paradigm of science. Science started with the empirical science, where we did experiments to explain what we can observe, right? That's before 1600. And then in the second phase was more theoretical. You build the physical laws and theoretical models. And in the third area is more computational. Use simulations, like massive simulations, and also to model, say, dynamics. But in the recent years, we move into data-driven approach with data mining, machine learning, massive data, and visualization, detecting of patterns, anomalies, and using AI and knowledge integration on to solve scientific challenges in the new era with a lot of data. So I want students to be familiar with this new era of doing work, including scientific work, including real-world challenges. So to do that, we ask students in my course at least to use real-world scale, and they use real-world data sets downloaded from the internet, and I provide them access to supercomputers through the Pittsburgh Supercomputer Center's Bridges 2 AI supercomputer, which was purchased with the National Science Foundation grant. And that supercomputer has millions of CPU cores and a few hundred thousands of, a few hundred of V100, H100 GPUs. So they have all this computing power at their fingertip. It's the matter of whether the student want to learn or not, right? So if they want to learn, we provide them the best tools they can use. And here are just some sample topics from the student projects in one of the semesters. You can see that because I give them freedom to choose their topics, so the range of topics can be quite a lot. Some of them even studied the emotional intelligence, some of them studied the speech emotion, some of them studied even high energy particle tracking, and on mental health, some studied sports, some studied spotted lanternflies, and some study yoga, and on and on. So you can see the topics are quite innovative and also covers a range of things. And for us as mentors, like me and my teaching assistant, we do 3 different things and try to reinforce each other. For example, classroom instruction, we teach them certain things so that they can run things on supercomputers, like computational skills, like MPI or deep learning. And we also teach them statistical skills, like time series, and literature search, and avoiding biases, and technical writing, for example, and on and on. And then we also give them assignments, like say project is one of them, and informal talk, and also Ignite talk, reading and information synthesis, formal presentations, peer reviews, and also leading discussions, and proposal writing and report writing. And we also give them feedback through, for example, face-to-face feedback. We ask them to come to my office as a team, and then we talk to them just like I would talk to a graduate student team. And we coach them, give them ideas on how they can complete their project so that they can solve real-world challenges. And we ask them to also show us milestone reports, and we provide them feedback. And they also do peer reviews of, for example, the talks. So as we go back to the earlier goals, right, because we wanted to prepare students with all these 4 different areas of skills, as I said, then I look at all the assignments, right? So on the left-hand side, I show you all the assignments in this course, and then on the right-hand side, I have all the 4 different skill areas. Then I can see that each assignment is mapped to one or more of the skills that I would like them to possess. And through this, it gives me confidence that the course is actually helping them to achieve the goal. Okay, so now I will briefly talk about the challenges we still face. And every semester, of course, we give them opportunity to give feedback, like the SRTE. So I carefully read their SRTE comments, and here are some of the things that students really like. For example, they like practical applied nature. They like, we help them to understand the current industrial practices. And also they appreciate the liberty and the open-ended projects so that make it more enjoyable and enriching. And also, despite the initial fear, students actually recognize the importance of public speaking, and they appreciate the focus on public speaking skills that we try to develop in this course. And they also appreciate one-on-one feedback we provide to them. And they also learn tools like Overleaf to write technical reports. And also they believe the course helped them to boost confidence in public speaking. And throughout the time, I also often hear back from students who have taken the course in the past but now are working. Some of them really expressed their appreciation for the course because they think the course prepared them for real-world challenges so that when they go out, they can immediately jump into a real-world problem, and they can also make use of the communication skills they have gained. However, there are still challenges, right? I still try to solve all the challenges in order to make the course even higher quality, right? For example, I found that it's really hard for students in the program to develop artistic sense, right? I think artistic sense need time to develop. You cannot teach it in one semester with all the other things you have to teach. So I found that, for example, students have hard time to develop very nice looking diagrams, or they have hard time to develop nice looking, PowerPoint slides. So all this artistic sense, I think, is still needed. And also, I wanted to encourage students to be more risk-taking and more innovative, but students want to get a good grade too, so there's a challenge, right? Many students don't want to take the risk, to work on a very, very ambitious project, but at the end, if they cannot finish it, then they can potentially jeopardize their GPA. So all these are understandable, but still, that's something I think as educators we need to try to let our students take more risk. And second area is teamwork, right? Despite how much I want students to work in teams well, but every semester there are uneven contributions from teammates. And thirdly, evolving curricula, right? The field is rapidly changing. Every year I teach the course, I have to change the reading assignments because just the things are evolving. There are new things coming out. And also diverse learning style. There are different students have different enthusiasm, different learning style. Some students, it's very easy to motivate them, but some others, it becomes very hard to do that. So as a conclusion, I see that we are already at 1 o'clock. So as a conclusion, we are always trying to improve our teaching, right? I'm sure all of my colleagues are trying to do that the same. But over the years, I believe I see teaching more of a reciprocal journey, right? Where students also taught me a lot of things. Over the years, my teaching style have changed, my teaching philosophy have changed, and I also developed new teaching skills. But I'm always committed to uphold all these core values, as I've already mentioned earlier, fostering critical thinking, promoting hands-on learning, encouraging lifelong learning, and also prioritizing student success. So I hope this talk has inspired you to reflect also on how we can all engage students more deeply in their learning journey. And once again, thank you for all the attendance and for this incredible recognition of the award. And I will be happy to entertain some questions. I will end the slide with a quote by Albert Einstein. Thank you.
Just a very mundane question. How do you evaluate the analysis of pen stroke?
The
brush strokes?
The brush stroke.
Yeah.
How do we evaluate the
Outcome of your analysis.
Oh, okay. That's a good question. That's a data science question. As I said, we cannot prove anything. So at the end of the day, because we have so many features we can extract from the brushstroke, so we can explain to art historian, for example, we believe, based on our analysis and probabilities, of course, this particular painting resembles the style of, say, a late period compared to an early period because of, curvy brushstroke, because of certain characteristics. So we can do all the explanations. But ultimately, of course, it's the art historian's decision whether they think this painting is done in the later period or in the early period. And our analysis serves more like a third eye for them to have additional evidence based on massive analysis of the numerical statistics from the painting. Yeah, so I don't think we can conclusively say any of the things we come up with, but I think the evidence is there. Okay.
Cool. So thanks, James. Great talk. I'm curious. You talked a lot about your trajectory over your career and some like perpetual problems at the end. I'm curious if there's one or two things that that you want to try to tackle in your teaching now that you'd like to see as improvements in the next, however many years as you go forward.
Yeah, I think the key thing I really wanted to tackle is to make students more risk-taking. But if they don't want to take the risk, then they may not be able to leverage the course as much, right? So I really want them to, think about a challenge that's real and that's large and that's innovative so that they can actually learn a lot from this challenge. Well, of course, we will provide them all the support for them to be able to solve that challenge, right? But ultimately, if they don't take on that kind of challenge, if they don't devote the number of hours we expect them to devote every week, then obviously they cannot learn enough from the course. So I think that's one thing I really want to change, because that's not something I can change alone, right? Because that's the interaction between me and students in the course. So, and I think if both sides want to do that, then potentially that can be changed.
Thanks.
Yeah.
Hi, James. Thank you for your talk. I love the reflection that you were doing at the end, and I'm wondering if you could say a little bit more about what was it that helped you as you were developing as a teacher to take risks yourself in moving your teaching forward?
Yeah, that's a great question. I think there are several things. One thing is that teaching evaluation, right? Because if I keep the old way of teaching, then, as I said, students were frustrated, I was frustrated, right? So I have to change. And then secondly, because this whole world is changing around us, right? If we don't change, the world is continuing going to leave us behind, right? So students have ChatGPT at their fingertip, right? They can ask questions directly to ChatGPT. So what would be the value that we can provide to the student that ChatGPT cannot provide, right? I think that's the kind of question. And also, what kind of skill set we can prepare students so that students can go out to do things that ChatGPT or other AI cannot do, right? So all of this prompted me to actually think about how we can change the way we teach.
Other questions?
Yeah, maybe another question.
You
Go ahead.
Yes, thanks for a great talk. I would like to learn a bit more about how you manage team projects. Because I'm teaching a course too that involves some working with teams, and I usually find the time slot rather limited.
Right, so that's an excellent question. When you have more teams in your class, it's really time consuming to meet with them individually. So what I do is that in the whole semester, I meet them 2 times on more like a regular schedule, so that we say, we give them like say 15 minutes to come to my office hour. Come to my office, and then we talk about their project. So in 15 minutes, they have to update me how they are doing in their project. Then I give them feedback. I and my TA give them feedback, but I only give them 15 minutes each time, so that they have to first prepare their appearance in my office. They need to tell me exactly how much help they need, and also how much progress they have made, and so that we can best use of the 15 minutes so we can give them enough feedback. And then we do it 2 times in the semester, and also we regularly provide them feedback on their written reports, right? Of course, as you know, when you have a lot of teams in your course, it's really hard to manage the time to talk to them individually, right? So that's exactly why I put this quote of Albert Einstein on the slide, because really we cannot standardize human beings, right? We need to give them individual feedback. If we just give them the same project for the whole class, it would be a lot easier to manage. But that would not make it interesting. Also, that would not make the learning experience valuable. So we have to find the right balance so that it won't burn us out, but at the same time, students will also gain enough valuable experience from the course.
You also talked about.
Yeah.
You also did mention their presentation skill. Do you have the whole class do presentations?
Yeah, we schedule them to give very short presentations during the class time, because the reason is that if we ask them to only record a talk and show it to me, that's a very different experience compared to talking to a whole class of 40 students, 50 students, right? So I do give them the experience of, say, giving them 5 minutes to give a talk on their project, right? So that they have to come up to the podium and talk. And then that talk can be partially peer reviewed. Also, so they not only have to convince me and my TA, but also they have to convince the entire class, and the score is averaged from all the peers. Yeah.
Okay. Thanks.
Sure.
One last question? I think that's a good stopping point, real positive.
Okay,
Thank you, James.
Thank you.
So